Hello, Luke. Welcome to lesson 89. Today, we're going to be talking about value problems. And this should be a pretty simple lesson. Essentially, you've already learned everything you need to know for this lesson. Value problems, we have been doing them all along, but we've been kind of calling them coin problems. Okay? So think back to all these story problems that you've done where they've given you two equalities in the word problem. They've told you that, there are 3 nickels and 5 dimes, or they've told you that the sum, of all the nickels are equal to the dimes plus 5, and that the total value is $4.65, and then they end up asking you how many of each coin do they have. So all of those problems would be considered value problems. And today we're just applying the same things we've learned with the coin problems to other scenarios. Okay, so let's just take a look at a couple of different story problems that they might give you. I've actually taken these right from the textbook for the lesson today. So that's, again, I didn't write these on my own. These came from the textbook. Let's just work our way through them. And if you can do these problems, you should be set for your seat work today. So let's read it. Airline fares for flights from Tifton to Adele are $30 for first class and $25 for tourist class. If a flight had 52 passengers who paid a total of $13.60, how many first class passengers were on the trip? Okay, so we need to find the two equalities here. There are two equations. So you can always just kind of write this out. There's two equations that we're looking for here. Okay, so what are they? Let's look at the first part. Airline fares for flights from Tifton to Adele are $30 for first class and $25 for tourist class. All right. So there are two kinds of tickets that we could be selling here. All right. So we need to get some variables going here. So let's call the tickets that we're looking for, or maybe the passengers. Maybe that'd be a better way to think of this. There are two kinds of passengers, and that corresponds to what they're asking in the end here. How many first class passengers were on the trip? So there's two kinds of passengers. We'll call it P sub F for first class passengers, and then we'll call it, maybe we'll write that, first class passengers. Okay, and then we could say P sub T for the tourist class passengers. Tourist class passengers. And this is generally kind of where you need to start. You need to figure out what variables are they asking for, and how are you going to denote them in the equations. All right, so now, once we've got our variables figured out here, we can then look for equations. So, if a flight had 52 passengers, so that tells us something right there. The flight had 52 passengers. Well, our variables here are numbers of passengers. We have the number of first class passengers, and we have the number of tourist class passengers. So, if this is the total number of passengers, well, then that would mean that we can make an equation out of this, because the total number of passengers is 52. How would I get to the total? I would simply add the number of first class passengers with the number of tourist class passengers, right? So the passengers for first class plus the passengers for tourist class, they should equal 52 passengers total. Okay? So there we go. That's the first equation here that we can come up with. Now the second equation has to do with cost. Okay, so we have kind of the count, and then we have the cost. Same thing as with our coin problems. It was the same scenario. So here we have the value 1360. So we know that the total expenditure for these passengers was $1,360. Okay. So how would you arrive at that total? I mean, what would you do? If you had all the information that you need, which we don't in this case, but let's just pretend we did, how would you arrive at $1,360? How would you compute that? Well, think about the process that you would use. You would take the number of first-class passengers and say, well, they all had to pay $30. So I'm going to take 30 times the number of first-class passengers, which I don't know that number, so I'm just using, again, my first-class passenger variable. All right. And then I would add that to $25 times the number of tourist class passengers. So I'd have to multiply or add that by 25 times the tourist passengers. All right? That's how I would do that, right? To get this total expenditure for all of the passengers. Okay? So that would be our second equation. There we go. There is our system of equations. Once we've gotten it to this point, and we feel confident that this is right, the rest is very straightforward. Now we can use our favorite solving method. We can use elimination. We could use substitution. Arguably, you could use graphing, although that's not going to produce as accurate a result. So in this case, I think I will use, let's use elimination. Well, no, let's use substitution. Let's use substitution here. So I'm going to take this first equation and solve for the passengers of the first class. And we do that by subtracting the p sub t from both sides, and we end up with 52 minus p sub t. And then I'll take this and plug it in to my second equation right here. Okay? So we have 30 times our p sub f, which we now know is 52 minus p sub t, plus 25 times p sub t equals 1,360. Okay, and we need a little more real estate here. Let's move this down. So now let's multiply this out. What is 30 times 50? Okay, 30 times 50, well, it's going to be 1,500, right? Oh, I'm sorry, 52. 30 times 52. I'm not seeing it right here. 52. Okay, so that'd be 1,560 minus 30 p sub t plus 25 p sub t equals 1,360. And now we can work this out. We subtract or combine the negative 30 and the 25. That's going to give me a negative 5 p sub t, right? Combining these two. And then if I move this 1,560 over to the other side, I'm going to have 1,360 minus 1,560. Hopefully I'm not skipping too many steps here. You're following me along. But this is all review, so I feel like we could probably speed it up here a little bit. So once we move that over, we can combine this side, and we have 1,360 minus 1,560 is going to give us what? Negative 200, right? So we have a negative 200 over here. We can divide both sides by a negative 5. Negatives become positive. We have a p sub t. Again, negatives will become positive. 200 divided by 5 is going to be 40. So p sub t is going to be equal to 40. Now remember what p sub t means. It means the passengers in the tourist class. All right? So knowing that now, we can say p sub t is equal to 40. We can plug that back in to this equation here, right? So p sub f is going to be equal to 52 minus the 40, the p sub t. And then p sub f is going to be equal to 12. So we have 12 first-class passengers, and we have, maybe I'll write it up here so that we can see it, 40 tourist class. Okay? And again, that does add up to 52 total passengers. And if we were to plug these in, we should end up that, the cost would be 1,360. Okay? So there you go. That's how we would work these. Again, it's very similar to the coin problems. We had kind of the count, the number of passengers, and then we had some sort of a value for those passengers, just like we had the count of coins and the value of coins. Okay? All right, let's go on to the next one. Wadakshaw's dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? Again, same sort of a situation. We have the count, kind of the number of dresses that have been sold, and then we also have the value, the cost or the income they received by selling that many dresses. Okay? So maybe pause the video, try this one on your own, and then we'll look at it together. All right, so let's figure out what our variables are going to be. So we're talking about dresses here. So we'll say maybe a D. Yeah, I don't like working with capital D's. Let's go with a lowercase d. So D for dress, and then we have to figure out, what would be the sub variable here. So let's call it D sub E for more expensive, and D sub, well, you know what? I don't like that either, because expensive kind of works for both. Let's go D sub L. D sub L for less expensive dresses. And maybe I should say this, the number of less expensive dresses. And then we go D sub M, which will be the number of more expensive dresses. All right, it's always important to define your variables first. And that's what we've just done. There, we've defined them. Now, what have they told us here? Because remember, we're trying to get two equations going here. So, they tell us what each dress cost, which is great, but that doesn't really give us an equation. And then they tell us the shop took in $1,375 worth, okay, and sold 20 more of the less expensive dresses than the more expensive dresses, okay? So, all right, there's a lot of information right there. First of all, we have kind of the value. The value of the dresses sold was $1,375, okay? And so if that's the value, how would you compute the value of all these dresses that are being sold? Well, you would take the number of dresses that are less expensive, right? The less expensive dresses, they cost $20 each. So we'll take the dresses that are less expensive and multiply that by 20. And then we're going to, actually, that's pretty tight here. Let's move that up. So we have 20 times the number of dresses that are less expensive, and then we're going to add that with the more expensive ones. The more expensive ones cost $45 each. So the $45 times the more expensive dresses, and that sum should give us $1,375, right? So there's one equation. Now what about the count? What do they tell us about how many dresses were sold? Well, they say that there were 20 more of the less expensive dresses sold than the more expensive dresses. All right? So if you think about that, you might have to think about it for a second, but they're saying that there are 20 more of the less expensive dresses. So if we have the less expensive dresses being D sub L, that's how many less expensive dresses were sold. And that's 20 more than the expensive dresses. So this number of less expensive is equal to 20 more than the expensive ones. So here's our expensive ones. It's equal to the expensive ones, to the more expensive ones, D sub M. But it's 20 more, this D sub L is 20 more than this. So we need to add 20 to the more expensive ones so that these two would be equal to each other. You following me? This is probably the trickiest part of the whole problem, is just getting this equation. We're saying that the number of less expensive dresses is equal to the number of more expensive dresses plus 20. Okay? Because they sold 20 more of the less expensive dresses. So we have 20 more on this side. right? If I just set it up as d sub L is equal to d sub M, I'm saying there's 20 more on this side. This side has 20 more. So therefore, I can't say that these two are equal, right? The only way I can say these two are equal is if I add 20 to this side. That would make these two sides equal. Following me? So make sure you understand where that 20 came from and how I decided where to put it. Okay. All right, so once we've gotten to this point, now we have our system of equations and we can solve. This one's pretty obvious. I think we're going to use the substitution method here because we already have d sub L is equal to something. So that makes it pretty easy. So we plug in this over here for all of our d sub L's in our second equation, and we have 20 times d sub M plus 20 plus the rest of this, 45 d sub M is equal to 1,375. And we multiply this out. We have 20 d sub M plus 400. 20 times 20 is 400. Plus 45 d sub M is equal to 1,375. Combine these, 20d and d sub M and 45 d sub M is going to be 65 d sub M. And then I'll move this 400 over to the other side, right? And what's that going to give me? That's going to give me 975 on the right. And then I can divide this out. So this side divided by 65, this side divided by 65. And I'm going to get d sub M is going to be equal to, let's see, what's 975? I'm cheating here. I'm going to a calculator. 975 divided by 65 is 15. So the number of more expensive dresses is 15. And if that's true, then what's the number of less expensive dresses? Well, we can plug this in for this, right? So d sub L is going to be equal to d sub M, which is 15, plus 20. So d sub L is going to be 35. So we have 35 less expensive dresses, 15 more expensive dresses. And just notice again that we have 20 more less expensive dresses than we do more expensive dresses, which is what we're saying up here. 20 more of the less expensive than the more expensive. Okay? All right. So hopefully you were able to get through both of those without any issues. If not, maybe just go back in the video and make sure you understand what you did wrong, because these are the kinds of problems they will be throwing at you in your lesson today, but also in future lessons as well. So good luck, and I will see you tomorrow.